Welcome back to Hoochos. Today on Hoochos, we're going to set up a comparison between DWC and Kratky. Now, I'm also going to release a 3D print in this video, as well as we're going to have a look at the differences between the two systems in the setup phase. Unfortunately, the video kind of took a weird dogleg at the end, and the results we get are extremely important, but they're not the results I expected. In this video, I'm actually going to cover one of the things that I've learned from this grow, which has answered the question to one of the biggest problems I've had with growing indoors, and that is necrosis of the new leaves and calcium deficiencies within indoor systems. So we're going to have a massive discussion at the end about how to get around these problems. So if you get bored at any point in the video, flick ahead. There's definitely information that I would recommend having a glance at if you're an indoor grower, and let's get to building the system. There will be 2 time lapses and there'll be timestamps in the description so that you can jump ahead to whichever part of the video you're most interested in. So let's get started. The things you'll need. So I'll be using squat black tubs. Now these are handy storage, food safe tubs. They are 30-litre tubs, and that means that we'll be able to house around 7 lettuce, because each lettuce over its lifetime, according to Dr. Kratky's journal articles, utilizes around 3 to 6 litres of water. So we're going to try and aim right in the center of that for about 4 litres of water. Each of these tubs will be able to sustain 7, but we'll go for 6, which gives us some wriggle room. And this also covers perfectly the area of which I will have a light hung over the top. There are 2 options for holding the lettuce above this system. The lids for these storage containers, these lids are actually sold separately. They're $10 a lid, and that gets rather expensive if you want to do any amount of them. So you can pay the $10 extra for the lid, or you can buy this. This is extruded foam board. Now, make sure it's extruded foam and not expanded foam. Expanded foam can have bubbles throughout. Extruded foam is just a consistent board of foam, and it doesn't cost much at all. It's exactly the same stuff we used in the Kratky video, and I've had it outside. It doesn't degrade, it stays in shape, and I've been rather impressed with this material. A board like this is between $10 and $15, which is about the same cost as the lid, and it will cover 3 systems. What I'll be doing today is I'll be cutting this to size and using this above our system. You'll also need, for the deep water culture system, an air pump. Now, a high volume air pump is a good choice. So this is the Aquaponics Infinity AP750R. So it's 750 litres per hour. And to go with that air pump, you're going to want some air stones. Now, the bigger the better. I'm going to be starting with this smaller size of air stone. And when I can get my hands on bigger ones, I will, because I just broke the air stone that I was going to use. There's also a 3D printable design that we'll get to a bit later in the video, but you do not need to use that. I'll give you an alternative if you don't have a 3D printer. So the setup for both systems is basically identical, with a couple more steps for your DWC system. What we're going to do is we're going to cut our foam to size. So you can just use a snap-off knife for this and use the containers to trace your way between them, like so, and same on the edge, like that. And now we have 2 lids. So from here we can drill out our holes where we want our plant spacing. So I'm going to mark that out, and we can either cut it out with a hole saw, which I'm going to do, or we can just cut it out with a knife. This gives you the option to create these systems without any power tools at all. So I'm just taking out the centerpiece of the hole saw, and it'll just make it easier for us to remove the foam from the center. I'm just going to mark out some nice wide spacings. So I'm just going to cut these holes out. Just be prepared for a mess, because it's going to happen. And don't hesitate, just push straight down into the foam. Okay, so now we've drilled out the holes in both our lids. The size of the hole that I've drilled in my lids is 44 millimeters, and that's because I'm using a 42 millimeter Jiffy peat pellet in a way that I showed you in another video using just the peat pellets and no net cups. You can actually drill these out to any net cup size that you have and then put the net cups in like I demonstrated in my first Kratky video. This is just a way of getting around the plant holding problem without any plastic whatsoever. So we'll actually be using the toothpick technique for all of these plants, and I'll show you how to do that in a second. That is our Kratky system basically set up. We can now take the extra steps to make our deep water culture system set up. For our deep water culture, we are going to need two extra things. We're going to need an air pump and air stones, and we're also going to need some way of keeping the air stones from moving around, because as important as getting the oxygen into the solution, we actually want to concentrate the oxygen that's being released and the bubbles and the spray coming off the water surface in a way that utilizes it best across all of the plants in the grow. So I'll be aiming to keep the air stones within a certain vicinity of all of the plants so that I get even growth throughout the system. So to do this, I've actually designed a 3D print. These are air stone holders. They're little saucers that hold the air stone in place, but also let the air to escape from underneath the air stone itself. So these will just be siliconed to the base of our container, and the way that I'll be arranging them is so that each air stone is positioned perfectly in between each of the plants so that we get the most oxygen to all of the plants that we possibly can. So I'm going to silicon that in place, and then we can add in our air stones and our pump. So they're now siliconed in place. They're not going anywhere. The prints are designed to hold a 50 millimeter air stone, but it makes it really easy to scale up or down. If you wanted to hold a 25 millimeter air stone, you would just scale it down half. And if you wanted to hold a larger air stone, although 50 is probably adequate for most applications, you can scale it up. So this will work with any sized spherical air stone. The alternative for those who don't have a 3D printer or are in a rush is a milk cap or any kind of cap that will stop that air stone from moving around when the pump is on and the roots get in there and do their thing. So the way that this works is the air stone that you scaled, your model 2, just drops straight in on top of your holder. That is where it stays the entirety of the grow. Now obviously nothing can go perfectly smoothly, and I've broken my second air stone, unfortunately. So I'll be using a smaller air stone in its place. I didn't realize this, but the gaps in the side serve a dual purpose and can hold your tubing in place if it is a smaller stone. So I'm going to show you what this achieves and how much water you're going to want in underneath your plants before you plant them. So what I'm going to do here is I'll be filling it to an inch underneath where the base of the grow media will be. Because what's going to happen is, as the bubbles rise, as we saw in our Oxypot video, when the bubbles pop, they're going to spray water up onto our grow media. And this is going to tease the roots down a lot faster than if it was just submerged within the water. So I'm going to stop it there. This is a 30-litre tub, and now we can have a look at what the air stones are going to achieve. It'll also be interesting to see the difference between a large air stone and a small air stone. So I'm going to turn the pump on. Okay, so really there isn't much difference between the two air stones, which is fantastic. It means that it's not going to change the results. It looks like the same amount of air is coming out of both. The bubbles on this seem to be smaller though. So the bubbles on this are larger, and there actually seems to be more splashing coming from the smaller stone, which is interesting, but that makes sense if the bubbles are bigger. The droplet size is bigger here and the droplet size is smaller here. Smaller is actually better for aeroponics, but what we're trying to achieve here is we're trying to just wet the roots and tease them down. That might be an experiment for another time. So you can see here against the black of my shirt, the little droplets jumping, and those little droplets are what's going to be delivering the nutrients initially to the roots. And the most growth is actually going to happen above the water where these droplets are being thrown up, because as with all hydroponic systems, oxygen is one of the most important components. Okay, so the Kratky system. How is it different? This is your basic Kratky system. It is a tub full of nutrient with a lid, and your plants start touching the nutrient, and as they utilize the nutrient, the water drops and you have a moist air gap. Now, rather than rely on power to supply oxygenated nutrient to the roots within a Kratky system will actually utilize the moist air gap above to grow air roots. So it's a completely different system of growing. The air roots will supply the plants with oxygen, and as the water drops, more air roots are created within that moist air gap. The water and nutrients are utilized from below, and they also use capillary action to move up the roots. You'll want this water to be filled all the way to the top for the Kratky, so that when we drop our plants in on top, they're just touching the water. If there is a slight gap, don't worry too much, because the roots will actually jump through the air and into the water because of that moist air gap. So the plants will find the water, don't worry too much. They want to survive. Let's set up our nutrient solution, which is the same for both. So I'm going to pre-adjust my water with pH adjuster. Add in my A and B nutrient. Calcium nitrate first, then all of the other, and we can test our solution. Nice. Okay, so I've got a pH of 6.5, so anywhere between 5.5 and 6.5. 6.5 is fine. Millisiemens, we're looking about 1.2 EC, which is, again, absolutely perfect for lettuce. And I think I might even do some bok choy. I'm going to do exactly the same for the Kratky and the DWC, and then we can put them under lights. Okay, so this is our setup. Above it, I've got the micro array. It's definitely overpowered for this application, but luckily it's dimmable, and I've got plenty of space to play with above. So I'm going to fill up this tub the exact same way as I filled up the other tub, just a little bit higher because it is Kratky. I can add in the air stones to the DWC system and add on our tops. And this is the part where I show you how we're going to hold our plants in the system. So all things going to plan. This is a video where I show you how to hold the plants within a Kratky system like this using only bamboo skewers. So all these plants are held in place using bamboo skewers, and the plant's roots grow around the skewers and allow the skewers to hold the weight of the plant rather than using any kind of net cup or other plant holding method. So we're going to do that again because it's working fantastically here. I'm really happy with how it's worked actually. And look at those roots. Those are some really nice, healthy roots. And that is just a Kratky style system. You can see how the plants are just held up by the bamboo skewers. Look at that, beautiful. And that is what I'm hoping to achieve in the Kratky system we're building here. And here we have another system that should be completed by the time this video comes out. This is the DIY seedling propagation shelving unit. So this is all DIY, made from hardware store light as well as shelves. Everything in here, even the propagators, came from a hardware store. And I think I'm going to change up what we're using today as our plants. I think we're going to go for some red pak choi. So as you can see, they're just babies at the moment, but that's absolutely fine. I'm happy with putting them in at this size, and the lighting in our DIY propagation system is working perfectly, as you can see here with our lettuce seedlings. So I'm going to steal a couple of these out and we'll plant them. So I'm going to plug the light in and I'm going to turn it right down as low as possible and we can plant out the cistern. And this is how it's going to work. We're going to pierce the side of our pellet and we just drop it straight in. It should fit perfectly. Hello. How you going? What's up? Come sit here. All right, you can help. Sit down. Sit. Good girl. And from here, we just push down until the pellet is all the way in, and that is our seedling planted. And we just rinse and repeat until all of our seedlings are planted. So you can see the difference in the water levels now. Okay, so that's all of our seedlings in place. Now all we have to do is turn on the pump and we've got our deep water culture system running. I'm gonna adjust the PAR as well. We've got a PAR of 64. I'm just gonna up that. I can actually lower the light rather than waste electricity. So that's a PAR of 270, 280. I actually wanna get that to about 250. So that's 246. 200 at the edges, 250 in the middle. I'll set up the time-lapse cameras and we'll see how they grow. So this is going to be an intermission segment where I've realized what is going on with the grow. I started having pest problems and I also started having the airflow problems, which we're about to discuss. Okay, so this is deep water culture versus Kratky. This is very interesting because I actually had one of the viewers in the comments on my Kratky video correct me as to why the leaves at the top were burning. And it wasn't because of the light intensity, it was because of a lack of airflow. And the lack of airflow caused calcium deficiencies because there wasn't enough transpiration or turgid pressure to pull the calcium up through the plant to the tips of the leaves, and the tips of the leaves suffered a calcium deficiency, which in turn caused necrosis of the tips of the leaves. So I'll show you what happened when I've actually added in this fan to this grow. Now, I'm probably going to have to redo this Kratky versus DWC. I'll include it in the video. The results are a bit tragic. I had to use pyrethrum on these because there was an insect infestation at one point, as you can see with some of the leaves. But I'll get you a bit closer because this is super interesting. You can see the color difference between the internal leaves here and the external leaves. Now the external leaves I've treated with pyrethrum. You can see where the insects were attacking the external leaves, but that's not the reason that they're this different color. The line in the sand, the point at which I put the fan on, is when these leaves started to produce through the center of the plant. So you can see the leaves are a lot healthier, and that is because of airflow within the environment, allowing all of the nutrients to be pulled up through the plant because of the raising of the transpiration rate due to the fan blowing across the leaves. Now that's actually something that I'd never thought would have such a great effect on the plants within an indoor system. All my outdoor plants, they get natural wind because of the shade cloth on the outside of my greenhouse. I don't have an impermeable greenhouse film. It's shade cloth, so the wind travels through the greenhouse and across the plants. So I've never ever had this necrosis of the tips of the leaves, such as this outdoors. I've now solved that problem, and you can see the solution in action. Let's resume the time lapse. This is where I'd kind of given up on the DWC versus Kratky, and we will revisit that in a future video because I really want to answer that question. So let's look at the rest of the time lapse where I've let the system go. We'll have a quick pan around the plants and we'll talk about airflow and the mechanisms of action that actually allow nutrient transport from the roots to the new shoots, the leaves, and the fruits that we want so that we can grow plants to their full growing potential.
I am omnipresent for thee, many fingers, many minds, and many eyeballs pop at my feet. I walk the streets, only supreme can see all that has been, all that will be. Third eye is free, I am nobody, tetrachromacy.
Okay, so at the end of that grow, I'd obviously given up on the deep water culture versus Kratky results. Although at the start, I really couldn't see much difference in the growth of both. So that's interesting, but we will have to delve into that a little deeper in the future. The thing that I obviously took away from that grow was the importance of airflow. And I've now amended all of my systems to include fans or some form of airflow that allows the air to pass across the plants, the heat to be removed, the humidity to be removed and replenished with fresh air that the plants can utilize. Now, to understand why this is important, we need to understand the physiological processes going on within the plants. And that means understanding water movement within the plants, because water is used to transport nutrients and every vital element that the plant utilizes from the roots all the way up to the leaf surfaces. So with that in mind, let's take a deeper look and gain a greater understanding of how this actually works. So essentially, plants capture light energy in the form of sunlight, or in this case, LED grow lights, and translate that energy into a useful chemical form in the form of carbohydrates through photosynthetic reactions that happen within the leaves of the plant. In addition to light, the plant also requires water and carbon dioxide to make the chemical process happen. Now, while the water is mainly absorbed through the roots, CO2 enters the plant through the leaves, through pores called stomata. While the stomata are open, absorbing CO2, water is lost through the stomata, and this is called transpiration. Transpiration is the process that drives movement throughout the plant, from the roots through the plant and into the atmosphere. At the leaves surfaces, the movement of air is reasonably still. The leaves are actually covered by what is called a boundary layer. Even with air passing over the leaf, the boundary layer persists. However, the faster the air moves across the boundary layer, the thinner the boundary layer becomes. The movement of water throughout this boundary layer and into the air is relatively slow. It's driven by diffusion, which is a passive action, but the more airflow there is, the faster that diffusion occurs. This is especially true when the relative humidity is extremely high. This rate of diffusion becomes extremely slow. So the more airflow and the less humidity you have, the more the plant will transpire and draw nutrients and water up through the plant itself. Now, the plant can actually regulate this flow by increasing or decreasing the size of the stomata. So an excess of airflow can be regulated by the plant, but a lack of airflow cannot be regulated by the plant because it cannot control the diffusion rate across its boundary layer on its leaves. So it can open its stomata wide open, but still not have any diffusion of water into the atmosphere, which will slow the water movement throughout the plant and can cause nutrient deficiency because there is no water movement, therefore there is no nutrient movement, and as the plant's growth outpaces the water movement, we find that the newer leaves start to necrosis because there aren't enough nutrients being transported to where they're needed for the growth of the plant. Now, as you can see with this system and the system behind me, I have now amended both of those systems with airflow, with fans, and they are both doing extremely well. Way better than any indoor systems that I've managed so far. And I've also got them on my seedlings. But a note with seedlings is that there is also something on the leaf called a cuticle, which is a waxy layer in between the stomata, which reduces water loss. Now, seedlings may not have a substantial cuticle, so that limitation of water loss within seedlings is something that you need to be mindful of. So be mindful of too much airflow over seedlings because it is very possible that you can dry out the propagation media and the seedling extremely fast because of their lack of that waxy layer, that cuticle which exists over the leaf's surface. And there it is. That is the surprising lesson I learned from my deep water culture versus Kratky hydroponic system comparison. I hope you enjoyed this episode of Hoochos. I am thoroughly grateful for the opportunity to learn the way I did, and all of my indoor hydroponic systems are going to benefit from now on from the lessons that I have learned. So, happy hydroponicking, and I'll see you next time on Hoochos. Got him.